Good morning, everyone. So our topic for today is mechanical wave.
Have you ever experienced to take surfing? Or you just saw a surfer who kept their pace on a big wave? What do you think is the reason why a surfer keep their momentum on the water? Yes, that's right. It is because of the immense wall of moving water that gives a surfer an amazing ride. This swelling surf will raise him up and push him forward as light as a feather. And that was an incredible power of the wave. So in this video, we will know how the wave transfer energy and travel through matter. Identify the various type of mechanical wave and how it will be measured.
First, let us define what is mechanical wave. A mechanical wave is a disturbance in matter that transfer energy from place to place. It requires medium in order to transport their energy from one location to another. For example, a drop of water falls into a pond. This disturbs the water in the pond. So what do you think will be happen next? The disturbance travel outward from the drop in all directions. So this is the wave. Remember, a source of energy is needed to start a mechanical wave. In this case, the energy comes from the falling drop of water. Next is the medium. The medium is the substance through which the wave travels. In ocean wave, water is the medium. In sound wave, air is the medium. So based on the previous video, the medium is a liquid, which is the water in the pond. But don't assume that a mechanical wave can only be traveled in any liquid form. And that was an absolutely wrong. Mechanical wave can be traveled in any state of matter, including a solid or a gas. So how about the particles in the medium? The particle of the medium just move back and forth or up and down in one spot. As the particle vibrate, they pass the energy of the disturbance to the particle next to them. Bear in your mind that the particles of the medium don't actually travel along the wave. It's only the energy travel. Another one is we have a type of mechanical wave. We will first discuss the transverse wave. A transverse wave is a wave in which the medium vibrates at right angle to the direction that the wave travels. For example, a transverse wave in a rope. In this wave, the energy is provided by a person's hand moving one end of the rope up and down. As you observe, the direction of the wave is perpendicular from the person's hand, and the rope also itself moves up and down as the wave passes through it. Next one is longitudinal wave. Longitudinal wave is a wave in which the medium vibrates in the same direction that the wave travels. For example, in this wave, the energy is provided by a person's hand pushing and pulling the spring. As you observe, the coil spring first crowd closer together and then spread apart as the disturbance passes through them. And the direction of the wave is the same with the direction in which the coil moves. Next one is how we will measure the wave. First, let us know the wave amplitude. The wave amplitude is the maximum distance the particle of a medium move from the resting position when a wave passes through. So how we will determine a wave amplitude? The answer is, it depends on the energy of the disturbance that causes the wave. A wave caused by disturbance with more energy has a greater amplitude. In this feature of the transfer wave show the crest, the throw, the amplitude, and the wavelength. Take note that the crest is the highest point of the wave. Throw is the lowest point of the wave. Regarding to its amplitude, it refers to the height of each crest above the resting position. So the resting position implies on where the particle would be in the absence of a wave. Take note that the higher the crest, the greater the amplitude. In this picture of longitudinal wave, it shows the wavelength, amplitude, and the rarefaction. The longitudinal wave amplitude is described as how compressed the particle of the medium become when the wave passes through. Remember, the closer together the particle, the greater the amplitude. Next one is wavelength. The wavelength is the distance between two corresponding points on adjacent wave, measured in meter, and related to the energy of wave. With this example, it shows that a wave that have a longer wavelength consists of high energy, while a shorter wavelength contains low energy with the same amplitude. On the other hand, wave frequency refers to the number of waves that pass a fixed point in a given amount of time. The SI unit for wave frequency is the hertz, where 1 hertz equals 1 wave passing a fixed point in 1 second. Imagine if you try to move the roof up and down quickly. You will observe that it will generate a higher frequency wave in a roof, meaning it takes more energy compared to the roof that you move in a slow motion that results on a lower frequency. Lastly is the wave speed. Wave speed refers to how far the wave travels in a given amount of time, such as how many meters it travels per second. Wave speed is not the same thing as wave frequency, but it is related to frequency and to wavelength. Remember, wave speed is also affected by the medium through which a wave travels. Additionally, the wave travels fastest through solid and slowest through gases. Based on the topic we discussed, we therefore conclude that a mechanical wave needs a source of energy and medium in order to travel and transfer energy from one place to another. The mechanical wave propagation is also divided into three, but we only discussed the two waves, namely transfer waves and longitudinal wave. The transfer wave is a wave on which the particle travels perpendicular to the same path where the wave travels, and also have a crest, which is the highest point, and throw, which is the lowest point. While the longitudinal wave, it is a wave wherein the particles move parallel to the direction of energy transport. And lastly, in order to measure the wave, we must need to determine the wave amplitude, which is referred to the maximum distance of a particle of a medium from the resting position. Wave speed is how far the wave travels. Frequency is the number of the wave that pass a fixed point in a given amount. And lastly is the wavelength, which refers to the distance of the wave, either crest to crest or throw to throw. Thank you for listening.